Thank you very much. I'm going to skip the remaining chapters now to the last chapter, and the very last section of the last chapter, the mother of all Burqas. One of the unhappiest spectacles to be seen on our streets today is the image of a woman swathed in shapeless black from head to toe, peering out at the world through a tiny slit. I should say that the streets that I normally walk are the streets of England. It probably isn't the case here. The burqa is not just an instrument of oppression of women and claustral repression of their liberty and their beauty, not just a token of egregious male cruelty and tragically cowed female submission. I want to use the narrow slit in the veil as a symbol of something else. Our eyes see the world through a narrow slit in the electromagnetic spectrum. Visible light is a chink of brightness in the vast dark spectrum, from radio waves at the long end to gamma rays at the short end. Quite how narrow is hard to appreciate and a challenge to convey. Imagine a giant black burqa with a vision slit of approximately the standard width, say about 1 inch. If the length of black cloth above the slit represents the shortwave end of the invisible spectrum, and if the length of black cloth below the slit represents the long-wave portion of the invisible spectrum, how long would the burqa have to be in order to accommodate a 1-inch slit to the same scale? It's hard to represent it sensibly without invoking logarithmic scales, so huge are the lengths we're dealing with. The last chapter of a book like this is no place to start tossing logarithms around, but you can take it from me that it would be the mother of all burqas. The 1-inch window of visible light is derisorily tiny compared with the miles and miles of black cloth representing the invisible part of the spectrum, from radio waves at the hem of the skirt to gamma rays at the top of the head. What science does for us is to widen the window. It opens up so wide that the imprisoning black garment drops away almost completely, exposing our senses to airy and exhilarating freedom. Optical telescopes use glass lenses and mirrors to scan the heavens, and what they see is stars that happen to be radiating in the narrow band of wavelengths that we call visible light. But other telescopes see in the X-ray or radio wavelengths and present to us a cornucopia of alternative night skies. On a smaller scale, cameras with appropriate filters can see in the ultraviolet and take photographs of flowers that show an alien range of stripes and spots that are visible to and seemingly designed for insect eyes, but which our unaided eyes can't see at all. Insect eyes have a spectral window of similar width to ours, but slightly shifted up the burqa. They are blind to red, and they see further into the ultraviolet than we do, into the ultraviolet garden. The metaphor of the narrow window of light broadening out into a spectacularly wide spectrum serves us in other areas of science. We live near the center of a cavernous museum of magnitudes, viewing the world with sense organs and nervous systems that are equipped to perceive and understand only a small middle range of sizes, moving at a middle range of speeds. We are at home with objects ranging in size from a few kilometers, the view from a mountaintop, to about 1/10 of a millimeter, the point of a pin. Outside this range, even our imagination is handicapped, and we need the help of instruments and of mathematics, which fortunately we can learn to deploy. The range of sizes, distances, or speeds with which our imaginations are comfortable is a tiny band set in the midst of a gigantic range of the possible, from the scale of quantum strangeness at the smaller end to the scale of Einsteinian cosmology at the larger. Our imaginations are forlornly under-equipped to cope with distances outside the narrow middle range of the ancestrally familiar. We try to visualize an electron as a tiny ball in orbit around a larger cluster of balls representing protons and neutrons. That isn't what it is like at all. Electrons are not like little balls. They are not like anything we recognize. It isn't clear that like even means anything when we try to fly too close to reality's further horizons. Our imaginations are not yet tooled up to penetrate the neighborhood of the quantum. Nothing at that scale behaves in the way matter, as we are evolved to think, ought to behave. Nor can we cope with the behavior of objects that move at some appreciable fraction of the speed of light. Common sense lets us down, because common sense evolved in a world where nothing moves very fast and nothing is very small or very large, the mundane world of the familiar, which I have dubbed middle world. At the end of a famous essay on possible worlds, the great biologist J.B.S. Haldane wrote, "Now my own suspicion is that the universe is not only queerer than we suppose, but queerer than we can suppose. I suspect that there are more things in heaven and earth than are dreamed of or can be dreamed of in any philosophy." How should we interpret Haldane's queerer than we can suppose? Queerer than can in principle be supposed, or just queerer than we can suppose, given the limitation of our brain's evolutionary apprenticeship in middle world? Could we, by training and practice, emancipate ourselves from middle world, tear off our black burqa, and achieve some sort of intuitive, as well as just mathematical, understanding of the very small, the very large, and the very fast? I genuinely don't know the answer, but I'm thrilled to be alive at a time when humanity is pushing against the limits of understanding. Even better, we may eventually discover that there are no limits. Thank you very much.